The spiral spring of a spring balance is 25 cm long when 5 Newton hangs on it, and 30 cm long when the weight is 10 Newton. What is the length of the spring if the weight is 3 Newton, assuming Hooke's law is obeyed? In this question, the first length given to us, L, let's say L1, we have 25 cm. With the first force apply, F1, that is 5 Newton. We know from Hooke's law, extension is the new length minus the original length. Based on these two arrangements, we can have A1 become 25 minus the original length. So we keep that for that equation 1. The next length given to us in that question, that is L2, which is 30 cm for a force of 10 Newton, which we apply. So the extension for this new length will be 30 minus the original length. We call this equation 2. That's to form equation 2. According to Hooke's law, force generally is given as the spring constant multiplied with the extension. We make clear the subject formula here. We have force all over the extension. We can derive an expression here, make an expression that says that F1 over extension 1 will be equal to force 2 all over extension 2, making in this format to substitute the values from the given values here. F1 here is 5. I'm writing 5 all over E1, that is equation 1, 25 minus the original length. F2 here is 10. E2 is 30 minus. Rearrange this equation. We'll have 5 bracket cross multiply 30 minus L, so not. Then we have 10 bracket 25 minus L naught. Opening the bracket, if we open the bracket, 5 times 30 will give you 150, 5 L naught, and this will give you 250, 10 L naught. So collect like 10 in this equation, that is 10 L naught minus 5 L naught. We have 250 minus 150. 250 minus 150. Making it mathematics, this kind of that, that's 5 L naught. 250 minus 150. That'll give us 100. From here, we can get the original length, which is 100 divided by 5. 100 divided by 5 to get the original length. That'll give us 20 cm. Now that we know the original length, we can proceed to find the force given to us in that question. The force is 3 Newton, and we are looking for the new length that will produce this L. Once again, applying Hooke's law, that says force is equals to KE. And in this situation, we have this force E. In this situation, E will become L minus the original length. That will give us E is equals to L minus 20 L minus 20. Let's go back to this equation here. This is 3. K. E, we have this. That is L minus 20. We can get K from one of the expression here. We can get K from one of the expression. If we work on K, from one of the expression which we have solved, K F over E, if we pick a force 5 Newton, that produces an extension. Force of 5 Newton. 5, one of the expression, we are picking this force here, 5 Newton, and it's extension here, producing by here. What I mean, this 5 Newton, we can get this extension produced from here, having it to be, so write that here, 25 minus 20 give us 5 cm. So I'm picking these two, the force is 5, extension is 5. Move back to this equation here, 5 over 5. That will give us K to be 1 Newton per cm, per centimeter. We move back here to this equation, bringing the K that we obtained from here, the K we obtained from here, which is 1. We have 3 is equals to 1 bracket L minus 20. We end up having 3 is equals to L minus 20, making L the subject of formula in this equation. Making L the subject of formula, we end up having 3 plus 20, that will give us 23 cm. So in this question here, the length is 23 cm for 3 Newton weights. That's the answer.